Howdy folks, welcome back. So in this video, I'm just going to quick go through the practice quiz and again, kind of give you an idea as to how I would go about solving the problems. Again, I recognize this by no means the only way, and in some cases, there might be a way that makes more sense to you. Again, as long as you end up with the correct answer at the end, it doesn't really make too much difference to me which method you take to get there. Again, this is just how I go about solving the problems because kind of got to start from somewhere. All right, so again, the first question is dealing with finding the equation of a line through a set of points. So again, the general equation for a line in point slope form is y minus y1 equals m times x minus x1, where y1 is a y coordinate of one of our points, x1 is an x coordinate of that point, and then m is my slope. All right, so again, your points are listed x coordinate first and y coordinate second. So we can say this x1 is -2, y1 is 5, and this is going to be our x2 would be 3, and y2 would be 1 there. All right. So yeah, so you have y1 in this case, I'm going to say is 5, x1 I'm going to say is -2, and then my slope is going to be the change in my y values, so y2 minus y1, divided by the change in my x values, so x2 minus x1. All right. So yeah, so plugging in these points into my slope formula, I have 1 minus 5 divided by 3 minus a -2. So when I do the arithmetic here, so we have 1 minus 5 is going to be -4, and 3 minus a -2 is going to be 5. So I'm taking this y1 equal to 5, x1 equal to -2, and my slope equal to -4/5, I end up with y minus y1, which is going to be 5, equals m, which is -4/5, times x minus a -2, which would end up being x plus 2. And I'm fine if you leave it like this. If you prefer to, you can also rewrite this in slope-intercept form by solving for y here. So you'd add 5 to each side and distribute the -4/5 through. But again, I'm fine if you just leave it in the point slope form. There. All right. The next two questions are dealing with solving quadratic equations. All right, so here you have the quadratic equation x minus 2 squared equals 4. All right, so there are a few different ways in which you can solve a quadratic equation. So here we have something involving my variable squared equaling a constant value. So what we can do here is we can use the square root property to solve this. So when we use the square root property, we can take the square root of both sides. And when we do that, we have to account for the plus or a minus. So here on the left-hand side, the square root and the square will cancel. So you have x minus 2 equals plus or minus square root of 4, which the square root of 4 is going to be 2. All right, so when to solve for x, we can add a 2 to each side. So we end up with x equals positive 2 plus 2, which would be 4, and -2 plus 2, which would end up being 0. That's one way you can solve it. You can also solve this by factoring. So to start off, I can distribute this x minus 2 squared. So again, x minus 2 squared is x minus 2 times x minus 2. So we're going to have x squared minus 2x minus 2x plus 4 equals 4. And then I can rewrite this in standard form. So I can subtract the 4 from each side. Again, standard form means I have everything on one side equaling 0 over on the other side. So you have x squared minus 4x, and then plus 4 and minus 4 are going to cancel out. So we're just going to have x squared minus 4x equals 0. But then we can factor this. We have a common factor of x in each of my terms, so I can factor in x out. So we have x times x minus 4 equals 0. And if you have a factored expression equaling 0, so again, this only works if you have it equals 0, you can just set each of your factors equal to 0. So we have x equals 0, and then we add 4 to each side to solve the second factor. So you have x equals positive 4. All right, so again, either method you choose to solve it, you'll end up with the same answer at the end. All right, and then the last question here is dealing with projectile motion. So here we have a toy rocket, so it's not internally powered, is launched straight up from the top of the building 50 feet tall at an initial velocity of 200 feet per second. The equation that models the height of the rocket above the ground is given by this. So my S is my height, equals negative 16t squared plus 200t plus 50. All right, so we're trying to find the amount that it will take for the rocket to reach the ground. So what time t will S equal 0? So you have 0 equals negative 16t squared plus 200t plus 50. All right. So most of the time, if I have a leading coefficient that is not equal to 1, most of the time I'm going to go ahead and use the quadratic formula to solve this. But again, regardless of which method you use, you'll end up with the same answer at the end. So it's just kind of a personal preference there. All right, so again, the quadratic formula is t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so it's just a matter of knowing our ABCs. All right, so your A is going to be whatever your leading coefficient is. So in this case, my A is going to be negative 16. B is going to be the coefficient in my middle term, so my linear term here. All right, and then C is going to be my constant term. There. Again, it's important that we do have it in standard form before we find out our ABCs, which in this case it is given us in the problem. All right. So then taking these numbers and plugging them into the quadratic formula, we have negative b, so that's going to be negative 200 plus or minus the square root of b squared, so that's going to be 200 squared minus 4 times a, which is negative 16, times c, which is 50, all divided by 2 times a, which is negative 16. All right, so doing the arithmetic here, so we have negative 200 plus or minus the square root. So if I take 200 squared minus 4 times negative 16 times 50, you have 43,200, all divided by negative 32 in this case. All right, which if I take the square root of 43,200, oh. Okay. All right. So yeah, so we have 200 squared minus 4 times negative 16 times c. All right. So yeah, so then we take the square root of that. So the square root is going to be a square root of the number 207.84609. All right, so yeah, so actually what we're going to do is we're just going to, and yeah, we want all this in the numerator. So we have plus square root of 43,200 divided by negative 32. We end up with negative 0.245. And when we take negative 200 minus the square root of 43,200 divided by negative 32, we end up with 12.745. All right. And again, each of these represents a time. So again, when solving a word problem, it's important that once you've solved your equation, you ask yourselves the two questions. The first question, again, does the answer make sense? Again, there's no mention of a time-traveling device of any shape or form in the problem, so we can ignore the ones that lead to a negative time value. So what we're left with is 12.745 seconds. And that's it. So again, that's just kind of how I go about solving the different problems. Again, if you have a way that makes more sense for you, by all means, as long as you end up with the correct answer at the end, um, yeah, the route you take to get there doesn't really, you don't necessarily have to do it the exact same way that I do it. So hopefully you found this helpful. In the meantime, have a lovely day, and I'll talk to you all later. Bye now.